All right. Hi, folks. Welcome to they're kind of like notes, but you're just filling in the rest of the lab. I chose to have my face in the corner just so I could wave and you could see my facial expressions, but I might close that out in a little bit. So just a heads up about the investigation. If you were not in class on Thursday or Friday, depending on which class you have, we just made up information for you. So you might see that you could curl your tongue even though you can't, and that's just because you didn't join our class for Thursday or Friday, depending on when you have class. Okay, so just a reminder that these numbers are based off of the fact that we actually know genetically what percentage of people actually can curl their tongue versus not, and so on. Also notice that they call detached earlobes free here. So if you cannot curl your tongue and you have an attached earlobe, you're a very small percentage like me. If you can curl your tongue and you don't have an attached earlobe, you are actually of the highest group, which is interesting because I think we actually had a lot of people who could curl and had attached, but we'll be able to tell. So a few key things to remind you of. These are new assumptions, which you've read hopefully in your reading guide. But each cell has to have counts, which means they have to be numbers. And that's because we're looking at categorical data, but we want to know how many people are blank in that category, right? Your counts must be independent. So it's a good thing that none of you are siblings because you actually would be dependent upon each other because, again, it's genetic whether you can curl your tongue or not. Random. We didn't necessarily randomize, but only because we wouldn't have enough data otherwise, and I just thought this would be a fun intro. So normally you'd want to get the data and then randomize, okay? What you're going to do for your M&M lab at some point, and then eventually your project. This represents less than 10%. Again, us as two stats classes are less than all of the statistics classes, less than 10% of all of the stats classes in the United States, or technically the world as well. So I like that one of you for your project actually showed that. So if you look at our classes, we have about 29 to 30 people. I think it's 30 actually, including me. And if you think about all the classes of students taking statistics in the United States even, that's probably like, let's estimate maybe half of the classes in each school. So let's estimate that it's like 10,000. So if you take 30 and divide it by 10,000, that's going to be 0.003, which is 0.03%, which is less than 10%. Anyway, that's how you can kind of check that. At least 5 individuals in each cell. So that means we should have at least 5 people that can't curl their tongue, blah, blah, blah. This might be tough for us because we have a small sample size, so we'll see where it goes, but we're just going to go with it. The problem we might run into is that our analysis isn't going to be 100%, which is okay for now. Okay, so we have all of our data. What I want you to do is pause the video because I'm going to actually have you fill in this chart for me. So you already have this information. I posted it on Friday. I want you to fill in this chart. So you want to literally go up to your table and count how many people have attached earlobes and can curl their tongue. So we're looking for yes, yeses. Then you want to look for yes, nos and put it here. Then no yeses and then no nos. And then total everything up. So once you're done pausing, I'll have this filled out so you can just kind of double check where you're at. But this is how you would put in the total. It's a contingency table. All right, so I made my face go away. But hopefully you guys were able to get the same numbers. And I just copied what I saw, but there are 34 people and that's what I got as a total. So hopefully you got the same thing. So just double check your numbers. So yes, yes was 9. No, yes was 3. Yes, no was 19, and no was 3. So we're under the 5, which Again, because this is our first attempt and it's not going to be perfect with our small amount of data, we're just going to go for it. The other thing that you might notice is that we have a much lower group of the no than we should. This should be more in line with the yes, because these should match. And then technically this should be the lowest, but we're going to just go with it. So just double check your numbers. Hopefully you're good with that. If you are copying down, just pause it. Okay. And then I also copied over this table for us too, so that you could see, because it's going to be a little bit confusing. Our yes, based off of the table was 9. And these are our observed count. This is always your data that you collect. So then our yes, no was 19. That was the most popular. And then no, yes was 3. And then no was 3. So we actually have a larger group of people that can curl their tongue than not, which is cool. You guys are just extraordinary. This is the key, though, because when we create our formula, you need to know how this works. So the expected count, this is a big one, is always going to be your total that you observed times your predicted fraction. So our total is actually 34. So I need to multiply that by the fraction that we predicted. So in general, people can curl their tongue and have attached earlobes. That's going to be a yes, is 3 out of 16. Okay, so our expected count for this, you in your calculator would do 34 times 3 out of 16, and it's saying about 6.375 people should have yes, which is a little bit lower than ours. Then you want to do the same thing. So again, total observed times the predicted fraction for a yes, no. And the predicted fraction for a yes, no is the most popular, which matches our data, and it's times 9 out of 16. And if you're wondering where I'm getting these numbers from, it was at the beginning of the top of the page. And that comes out to 34 times 9 out of 16 is about 19.125. And leave these as decimals because they're expected. So it's not like real people, it's what you expect to get. And that's pretty cool because it matches what we got, which is nice. Then this is 34 times, so that's a no, yes, which is our lowest category. So that's 1 out of 16. And that comes out to, really, you could just do 34 over 16. So it's about 2.125 people. And then the nice thing about this one is it's the same because you have 3 people. Well, it should not be the same. Actually, it should be higher. But our predicted for this is the 3 out of 16. Again, so you can just steal your answer from up here because it's the same fraction. So 6.375. So we had a little bit more people having attached earlobes than we thought and could curl their tongue. And we had a little bit less people that can't curl their tongue and have free earlobes than should be expected, basically. Okay. Whenever you create a null hypothesis here, you can do it in words if it's something like a predicted value. So if you're given a prediction, you can just literally use the same thing every time. So if your alternate, it says the proportions of some of the traits are not as predicted. Think about what you think the null hypothesis is going to be. That's right. It's the proportions of some of the traits are as predicted. So you can't say that all of them are going to be exactly as predicted because that would be like really, really ridiculous and we would just have a perfect class, which we do, but not exactly data-wise. And if I'm going too fast for you, please feel free to pause it and write in what you need. But the alternate was already done, so this is our null. So this is good to go. That is our null, okay? And then our next step is going to be to figure out our degrees of freedom. So n is the number of categories, not the number of people. So just be careful there. In this case, our number of categories is 4, right? So if you look at your table, you have 4 different options. You either have a curled tongue and attached earlobes, you can curl your tongue, or you don't have attached earlobes, and so on. So if you're doing n-1, the reason it's n-1 is because it gets rid of a little bit of error that we end up with. So your degrees of freedom is 3. We're going to use that a little bit later, okay? This is hopefully very familiar to you because it kind of looks like our standard deviation formula that we used to use. This is going to be for something called a chi-square value. So chi is the Greek letter that's here, and it means it's finding a value that represents how related the categories are to each other. So you're trying to see how close our data is to the predictions, basically. And I think we're going to be a little bit off, but we can see how close we are. So basically, you're trying to prove whether this is true. It's the same idea as before. You either reject or fail to reject. So if your null is that the proportions of some of the traits are as predicted, we're going to see how far off we are, if it's statistically significant or not. And it's very similar to what we've done before. Okay, so the difference is that we're going to copy over our table from above and put it here. So I can actually just go up here and copy this. And I'm going to put them here. Okay, and we don't need the work for the expected count. If you want to delete that, you can, or you could leave it, doesn't really matter. But definitely leave them as decimals. Okay, and eventually I'll show you how to do this in the graphing calculator, but depending on how long this is, we'll see. All right, so what you want to do is, actually we'll do it in the graphing calculator just because it'll make our lives easier and we don't have to actually do this out in our heads. So we're going to do observed minus expected. So what I would like for you to do is enter the observed into L1 and your expected into L2. So we're going to do that. If I can move this out of the way, maybe. All right, so we are back to our graphing calculator. Sorry, I was having difficulty with that little taskbar showing up. So enter in your 91933 into L1 and L2. Because we have decimals that are nice, you can actually just type them in. But if you ever need to, you can actually do the math in here. So I could just do 34 times my predicted fraction like I had before, which was 3 out of 16. And it actually just gives you the decimal, which is nice. Again, you don't have to do that right now because these are nice decimals. But if they don't come out perfect like this, you want to make sure you do that because otherwise your answers are going to be a little bit off. Oh, goodness gracious. Okay, 2.125. Okay, and then we have 6.375 again. Okay, so in L3, the part of the formula that's showing up now is that we want to subtract our observed and our expected. So you're really going to highlight your L3 like we were used to doing. Second 1 to highlight L1 because that's our observed, minus second 2 for our expected. Okay, and that's nice because it just gives us the values. So then you want to type those into your screen here. If you want to wait and just type it in all at once, that's okay too. But I'm just going to move this out of the way so it's not on that side so we can see the other part better. Okay, so the next part of the formula is to take those numbers and square them. So again, I can go over to L4 and I'm going to square L3's numbers. So I can say I'm going to take L3, so second 3, and I'm going to square them. And again, if I'm going too fast, feel free to pause the video and do that out. Okay, then L5, oh, the baby is like tickling me. Sorry. Okay, so you're taking L4 now and you're dividing it by your expected value. Just a reminder, your expected values are all in L2. So in L5, I'm going to say I'm going to take L4, which is second 4, and I'm going to divide it by L2 because that's where my expected values are from. Now, if you hit enter, just be careful. The second value is basically 0. It's like 0.0008. So just write it as 0.008 just so you have it. But I'm going to have you copy these all into this table. So just pause the video, copy them over to the table, and then we'll do our last little step. Okay, so just a reminder of where this formula is going. We kind of broke it down by the table. Notice this last step is going to be to find the sum. So hopefully you copied all your values into your table, but we want this number. We want the sum. So in our calculator, we are finding the sum of all the values in L5. So what I would actually do, there's a few different ways to do it, but the easiest way that we're used to doing is go to second mode to quit. You're going to go to stat calc. And if you're ever behind, you can also notice like what I'm clicking down here. One variable stats, because that's where I want to get my data from. And then we actually want to get our data from L5, so second 5. The frequency we don't want because it's just a frequency of 1. If you hit calculate, notice that we want the sum. So the let's round it to 3.23. So that is actually our chi-square value, 3.23. Now, the other way to do that is to use the sum feature in math. You can actually use that anytime you need to, but it is under, you can either use 0. The faster way to do it is actually under, oh yeah, no, that's it. Sorry, I lied. It's under math. So if you do math and then sum, it's also in category. So if you do, or catalog, sorry. So if you do catalog and you scroll to S's, that's another place to find it. I'm not going to go through each of these options because the first option is like what we're used to doing anyway. But if you scroll down to the S's and you go to sum, I'm sure some of you are like, I get it, please move on. But if you do sum and then you type in L5, it would do that as well. But I like just what we're used to, the stat one variable stats, because we've done it so many times. Okay, so last little bit here, guys, and then we're done. So if you have our chi-squared value, it's 3.23. From the table, we want to figure out some values. A key thing here, this is your chi-squared calculated, okay? If your chi-square is based off of this, so our chi-square is actually 3.23. This is called a chi-square critical value, these numbers here, okay? What it's saying is if your chi-square calculated is greater than the critical value, you're going to reject. Now, we need to find our critical value. We had a degree of freedom of 3. So I actually want to focus on this row right here. So our chi-squared value has to be greater than 7.81 in order to reject. This is from a table in the back of your book, but you guys will be able to just use this paper on an assessment, so you don't have to actually like search for it, which is nice. Eventually, we're going to just be putting data in, and you'll actually be able to do a chi-square calculated on in your calculator, which is really convenient. But this is, if I ever say to show work, this is what I'm asking you to do, is make this table. Okay, so because our chi-square calculated is not greater than 7.81, we actually are going to fail to reject, because it says reject HO if blank. Okay, our chi-squared value is not greater than 7.81. It's much, and that's the wrong 2. Sorry. Okay, so we fail to reject. What does that mean though? So this is our last little bit here. If we fail to reject, what does that mean about our tongues and earlobes? Okay. If we're failing to reject our null hypothesis, what that actually means, weirdly enough, even though it looked like our data was really far off, is that we can actually just go up here and copy, especially if you already have this open. If you're failing to reject this, it means that this is true. And it means the proportions of some of the traits and you can throw in of our class are as predicted. And actually, like most of our numbers pretty much were in line with what it should be. The only one that wasn't was the no, right? That should have been a little bit higher, but otherwise it's good. One more thing, and then we're out of here, I promise. This is just an alternative method to checking your results. I do want you to do this because this is really important, especially those of us who didn't get it in the raft from chapter 20. You need to find your p-value. We already have our data into L1 and L2, so you can skip this step, which is kind of nice. It says, and this is actually how you're going to find your chi-square in the future most of the time, but if you go to now stat and then tests, we want to look for the chi-square goodness of fit. It's not, just be careful, it's not C, it's D. If I can actually let this scroll down, that would be helpful. Come on. Really doesn't like D for some reason. Anyway, the goodness of fit is the key here. We're eventually going to do the chi-square test from a table, which is a little bit different. That's if you're not given your predicted values. But because we were given the predictions at the beginning, you want the goodness of fit. Again, this is always if you're given a predicted value for what you should be getting for data, okay? So I click this. I already have L1 and L2 good to go. Just be careful, our degrees of freedom here are 3. The color doesn't matter because we're not going to draw it. If you want to try and play with that, you can, but we just want to go to calculate, okay? Our chi-squared value that we did by hand matches what we had here. And the other nice thing is I have a p-value. Notice that that is not less than 0.05. Okay, the significance level we use is the same for confidence intervals. So I'm just going to type out the note here. Our p-value was equal to, what was it? 0.36 for our class, which is 36%. So basically that means you have a 36% chance that it's statistically significant. So it's pretty small. So the significance level is usually 5%. It has to be less than 5%. So basically your null hypothesis has to have less than a 5% chance of being true for you to reject it. We have a large enough percentage that we're actually good to go and say that our null hypothesis is close. Now, it's not great. We're like not super close to what it should be, right? The closer to 100%, the more accurate it is. But that 36% is not less than 0.05, which means we are going to, again, fail to reject because it's not less than 5% or 0.05. Okay, so just be careful, those of us who had confused that before. All right, so we failed to reject. And again, this is what it means. So eventually, we're going to go through chapter 20 notes next class. I'm going to break it up into 2 days so you have a little bit of practice too. But Thursday and Friday, we're going to do an M&M lab where I'll give you the data, especially if you don't have M&Ms at home. If you do, great. You can just use the data that you have. But it's going to be more on your own because it looks very similar to this. So use this to help you with that. And I'm going to give you a little grade for it. So it'll hopefully be a grade booster for most of us, but you're going to have a little bit more time to do things. I know the raft was a lot this week, or last week. So hopefully easing up a little bit is going to help. Enjoy the rest of your day. And I hope this all made sense. If it didn't, feel free to join my office hours.